to look at algebraic expressions. Algebraic expressions. For today, algebraic expressions. Now, we're going to start with a simplification of algebraic expression. Simplification of algebraic expressions. How to simplify. How to simplify algebraic expressions. Now, let's look at the first example. And the question asks us to simplify minus x plus z plus 3y. So that is our question. So you simplify 3x minus x plus z plus 3y. So let us look at the solution on how to solve this. Now, what you are simply going to do is to collect the like terms together. So for instance, we have 3x, we have negative x. So you collect them. Then 4y and 3y, you collected them together. So we start with 3x. You're going to collect it with negative x. Then 4y plus 3y. 4y plus 3y. Then we have z, which is now plus z. Now 3x minus x, you're going to get 2x. Then 4y plus 3y, you're going to get 7y. Now it is now plus 7y, then plus z. That is how you simplify an algebraic expression. That is now simplified. We've collected the like terms together, collected them, and we arrive at our answer as 2x plus 7y plus z. So that is it. Let us look at another example too. Simplify simplify 2x minus 6y minus 4x plus 52 minus y. So you simplify 2x minus 6y minus 4x, then plus 52 equals to 52 minus y. Sorry, this is not 52. This is 5z. Sorry, it is a 5z. 5z. Now let us look on solution on how to solve this. So it is a 2x minus 6y minus 4x plus 5z minus y. So we collect like terms together. So you're having 2x minus 4x minus 6y minus y, then plus 5z. So 2x minus 4x, we have negative 2x. Then negative 6y minus y, we have negative 7y. That is now minus 7y plus 5z. That is how simple that one is worked out. That's now let's move to the other example, example 3. Then we're having a fraction, so simplify as oh, that's simple. We're simply going to collect like terms together. That is half a plus a quarter a plus a quarter a, then minus what? Minus a third b. Minus a third b. So we shall have, that is a 3/4 a minus a third b. 3/4 a minus a third b. Now, having our fraction, find the LCM. LCM is 12. 4 into 12, 3. 3 times 3, 9. So we shall have 9a minus 3 to 12, 4. 4 times that, 4b. So we shall have 9a minus 4b as our answer. 9a minus 4b over 12. This is now our answer. 9a minus 4b over 12, which is the LCM. So that one becomes your correct answer. Correct answer. Let us move to another example. We shall look at more examples on this. Example 4. Now simplify a plus b over 2 minus 2a minus b over 3. Simplify that. A plus b over 2 minus 2a minus b over 3. That's it. So under solution, let us look at this. We are having a plus b over 2 minus 2a minus b over 3. So what we do, we look at the LCM for the 2. And the LCM is 6. For 2 and 3 is 6. Now 2 into 3 into 6, that is 3 times. So multiply 3 times a plus b. So we shall have 3 into a plus b. Then it is a minus. Now 3 into 6, 2. 2 times 2a minus b. Now multiply. That one will give us 3 times a, that is 3a, plus 3b minus 4a plus 2b over 6. So we collect the like terms together. There we shall have 3a minus 4a, then plus 3b, then plus 2b, plus 2b. That means 3a minus 4a, we shall have negative a, then plus 5b divided by 6. That one now becomes our simplified answer. So if you take a plus b over 2 minus 2a minus b over 3, your answer will be negative a plus 5b over 6. That is your simplified answer. Simplified answer. Good. Now, I want us to move to the brackets. That is algebraic expressions in brackets, how to solve them. So let's look at the brackets. When they're in brackets, how do we solve them? Look at these examples. Now remove the bracket and simplify. Remove the brackets and simplify. We're having a as 3 into a plus b minus 2 into a minus b. 3 into a plus b minus 2 into. That is simple. All you have to do is open the brackets and collect like terms together. So let us look at the solution. Just open up the brackets and collect like terms. So 3 times a, that is 3a, plus 3b minus 2a plus 2b. That's simple. That's simple. Now collecting like terms together, 3a will be minus 2a, then you add plus 3b plus 2b. 3a minus 2a, you get a plus 5b plus 5b, and that one now becomes your final answer. You've simplified this algebraic expression. So 3 into a plus b minus 2 into a minus b is simply a plus 5b. A plus 5b. Let's look at the second example in brackets. We have 5 minus 6 into a minus 3b minus 8. Minus 8. Minus 8. Now, having that, we can now look for a solution for that. So what we're going to do is open up the brackets first, then collect like terms. Therefore, we're going to have 5 minus, so open the brackets. So 6 times a, that is 6a, minus 6 times 3b. 6 times 3b, we're going to get 18b. So that is, we're having negative 6 times that, so we shall have positive 18b, then positive 48, I mean. 48, that is 6 times 8, that is 48. 48. Now we can now collect like terms together. Negative 6a plus 18b plus 48. So 5 will move to the other side, this side. Then we shall add 2 plus 5. So our final answer will be negative 6a plus 18b, now plus 53 plus 53. So that one becomes our answer. 5 minus that, get this as your answer. Very simple. Another one, we have this. Look at this. See, we are having a third a plus 3 into 5a plus b minus c. B minus c. You can look at this equation, then you get scared. But this is how you simply work it out. First of all, open the brackets. So you're going to have a third a plus, when you open the brackets, 3 times 5a, you get 15a plus 3b minus 3c. That is how we open the brackets. Now we collect like terms together. So we're going to collect, we are simply having a third a plus 15a. Then the rest can remain. So a third plus 15, that is 15 and a third. That is now 15, a third a plus 3b minus 3c. And that is your correct answer, which is simplified. You can see how simple algebraic expressions are. Then the last on that, on brackets, we can have this as our last example. We are having 2b plus a, then brackets 3 minus 2, and then we have another bracket here, a minus 5, that way. So we start by opening the brackets inside the bigger brackets. So we are going to have 2b plus a into 3, so minus 2 times a. So you are going to have minus 2a So minus 2 times 5, we're going to have plus 10 that way. Now we have to open now the second brackets. So we are going to have 2b plus 3a minus 2a squared, that is negative a times negative 2a, that is will be negative 2a squared, plus 10a. That is how we open the brackets. That is how we open the brackets. Then we collect the like terms together now. We can now collect the like terms. So you're having 2b, it's alone. Then we have 3a and 10a. You have to collect them, but 2a squared is not the same as a. Therefore, we're going to collect 2a, I mean 3a plus 10a. Then we're going to get 13. So our answer will be 2b plus 3 plus 10, which is 13a, minus 2a squared. That one becomes our answer as 2b plus 13a minus 2a squared. 2a squared. That's simple. That is how we work out brackets in algebraic expression. You simply open up, then you collect like terms together. That is how you end up simplifying the whole thing. Now, let us look at something small on factorizing. 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 We're still looking at the algebraic expressions. Let us look at a few examples on factorizing. And the question reads, factorize each of the following. Factorize each of the factorize each of the following. A, we're having 2a plus 4b plus 3a plus 6b. 2a plus 4b plus 3a plus 6b. We simply want you to factorize. Factorize. So when it comes to factorizing, it's like the reverse of simplifying. So, like for this question, let us look at the solution so that you understand what we mean by factorizing. Now, first of all, collect the like terms together. Collect the like terms together. So here we have 2a. It is with 3a, now plus 3a, plus 4b, then plus 6b. Now we are having 5a after adding plus 10b. 5a plus 10b. Now 5a and 10b, we have 5 is common. 5 is common. 5 is common. And therefore we can factorize, or we can factor it out. 5a plus 10b. Therefore, we can have 5. Let us factor it out. We shall have 5 into 5a is a plus 5 into 10b is 2b. That is how you factorize. Now your answer becomes 5a plus 2b as your answer. That is it. So you simply factor out when you are having a common factor, you factorize it out so that you have your answer like that. Let us look at this b. We're having a r cubed plus a r power 4 plus a r power 5. So ar power 3 plus ar power 4 plus ar power 5. So under solution, can't there's no, you can't collect like terms together. There's no like term there, but there is a common factor. Now here, the common factor that is appearing on both is a r cubed, which is common. It is common. Ar cubed, which is common. So we can factor it out. So ar cubed into ar cubed itaenda once, that is 1, plus into ar power 4, we shall remain with r and alone, then plus ar cubed into ar power 5, we shall remain with r squared. And that is how you arrive at your final answer. So you factor out ar cubed, and this is what you get as your answer. 1 plus ar cubed into 1 plus r squared. That is, if you want to get your answer, you simply have to open your brackets. So ar cubed times 1, you get ar cubed is 1. Then ar cubed times r, you're only going to add another r. So you shall have ar power 4. Then ar cubed times r squared. We're going to get ar, then r power 5, adding the powers. Good. So that is it. Then you can look at another example on the same, on factorizing. We have a squared p cubed minus a p squared plus a cubed p, a cubed p. So that is the question. We now look at the solution. So you can see we have a squared p cubed minus a p squared plus a p. Now, from this equation, we can see a common factor, something that is appearing on each. So we have a p as is common. AP is common. You can see here we have a p, then AP is common here, then AP is common here. So we have AP as our common factor. So AP, we factor it out. So AP into a squared p cubed, we shall remain with a Then p, we shall remain with p squared minus ap into a p squared. So a, we shall have no a, so we shall have p minus p. 1p will remain. Then plus a cubed, a cubed we shall remain with a squared. Then p will end. That is how we get our final answer when we factorize. So we shall have ap into ap squared minus p plus a squared. Good. Okay, last example on that. Before we look at something else, so we're having 4x squared y plus 20 x power 4 y squared minus 36 x cubed y. 4x squared y minus that is plus 20x cubed x power 4 y squared minus 36 x cubed y. Now let us look for a common factor here. So a common factor, first of all, we have 4, 4, 4, 4. 4 can be common. We have 4. We are looking at the solution. 4 and then x squared, x squared, x squared, 4x squared, then y, y, y. So y. So 4x squared y is common. Is common. 4x squared y is common. You now factor it out. Factor it out. So we have 4x squared y into, now into 4x squared y. That will be 1s. 1 plus. Now 4 into 20, we have 5. Then x into x power 4, x squared into x power 4, we shall have x squared. Then y into y squared, we shall have y. So we have 5x squared y. Then minus 4 into 36 is 9. Then x squared into x cubed will remain with x. Then y into y, 1. Therefore, we shall have 9x. That one becomes our final answer. So that is how we factor the algebraic expressions. Algebraic expressions. Now, let us look at this example. Let me see if you can interpret this example. And call it example 2. Now, find the area. Find the area of the shaded region below, leaving your answer in terms of pi. In terms of pi. So we have this figure, or rather a circle. So the shaded region, this is the shaded. That is the shaded. So now find the area of the shaded region below, leaving your answer in terms of pi. So you leave pi the way it is. So we all know the area of a circle. Area of a circle is pi r squared. Now to find the area of the shaded region, you're going to find the area of the biggest circle, which is pi r squared. Sorry, let me use this big R, pi r squared minus the area of the smaller one, which will be pi r squared. Can you see the difference? You have big R and a small r. So that is how we find the area of the shaded region. Now, having this, we have something in common, for common factor. So you can say pi is common. You can see pi here and pi here. So pi is common. So we factor it out. Therefore, we shall have pi into r squared minus r squared. Then close your brackets. That is now your answer. The area for the shaded region is pi into r squared minus r squared. That's simple. So that is how you find that. That is an algebraic expression of which you factor out pi. So your answer, you've left your answer in terms of pi. So you don't have to substitute. Now, we can look at the last part of this lesson, and it's going to cover on algebraic fractions. We can look at 3 examples, then we have it. So we're going to look at algebraic fractions. Algebraic fractions. Look at this example. Algebraic fractions. And one, express each of the following is a single fraction. So A, we have x minus 1 over plus 2 over 4 plus x over 5. That's x over 5. So x minus 1 over 2 plus x plus 2 over 4. Now you simply ask to express it as a single fraction. So this is simple, very simple. All you have to do is find the LCM, then work out. So under solution, so you're having x minus minus 1 over 2 plus x plus 2 over 4 plus x over 5. Now, this will be equal to, find the LCM for 3. What is the LCM? 2, 4, and 5, that is 20. 20 is the LCM. Now, 2 into 20, that is 5 times. Now, 5 into x minus 1, that way. Sorry, 2 into 20, that is 10 times, sorry. 10 times, not 5, that is 10 times. So I shall have 10 into x minus 20. Then we are adding, then 4 into 20. 4 into 20, we are having 5 times. So 5 into x plus 2. 5 into x plus 2. Then plus 5 into 20, that is 4 times. So we're going to have 4 times x, that is 4x. Now we open those brackets. We have 10x minus 10 plus 5x plus 10, then plus 4x over 20. Over 20. Now, this negative 10 and 10 will cancel out, and we are going to remain with 10x plus 5x plus 4x. That is 15 plus 4, 19 by 20. So we are going to have 19x over 20. So that is our answer. So our answer becomes 19x over 20. That is how we solve this algebraic expression. 19x over 20 becomes our answer. Then we can look at example B. Let us look at B. B, we are having A, B. So we are having that. So we can look at the solution for this. Now, we look for the LCM of the two. So we're having A plus B over A minus B minus A over B will be equal to, find the LCM A and B, that is AB, is the LCM. A into A and B, that is B, so B into A plus B. Now, B into AB, that is A, now minus A into B minus A. Now we open the brackets. B times A, that is AB plus B squared minus A times B, that is AB. Then minus minus plus A squared plus A squared. Therefore, AB and AB, negative AB will cancel out. It is all over AB. The two will cancel out, and you're going to remain with B squared plus A squared over AB. That is how simple that is. You get your answers: B squared plus A squared which will be equal to AB. That's simple. Now, let us look at the last example on that. That's the last example. Last example, let's have this. The last one. 1 over 3 into A plus B, then plus 3 over 8 into A plus B, then plus 5 over 12A. That is, you're given such, you're asked to express in as a single fraction. So you express it as a single fraction. As a single fraction. Now let us look at the solution. Someone may wonder, how are you going to solve this now? Let me show you. We are having 1 over 3 into A plus B. Then we are having plus 3 over 8 into A plus B. Then plus 5 over 12A. Now, we look at the LCM for the denominator. So we are having 3 into A plus B, 8 into A plus B, then we are having 12A. Therefore, you can see A plus B is common here, A plus B is common here, but we have A moving around. Then we have all numbers which is 3, 8, and 12. 3, 8, and 12, they have a common LCM, and that is 24. So we're having 24. Then we are also having A, which is common everywhere, A. So 24A. Now, into brackets A plus B. We are multiplying with A plus B. So we are having 24A everywhere. Then we are having A plus B. So we are going to multiply 24A by A plus B. So that one becomes our LCM. So our LCM is 24A into A plus B. So that we start now working out. Now 3 into 24A into A plus B, we shall have 3 into that, into 24. It goes how many times? 8 times. So we'll have 8A. So 8A plus 8A plus, now we are having 9A. We are having 9 plus 9A, good, plus 9A. Then plus 10A. So this one it end up mara 5 times that. Nimemaliza 3 times 3. 8 into that into 24 is 3. That is 3 times 3. Inakuwa 9A. Then plus 9A plus, then 12 into 24, it's 2. 2 times 5, that is 10. 10, but A inaenda once, we are remaining with 10 plus 10A. Then we have another B, 10B, 10A plus 10B. So you're having 8A plus 9A plus 10a plus 10b. Now we collect our like terms together now. Now start collecting. 8a plus 9a, we are having 8a plus 9a. We're also having 10a. So you're going to have 17 plus 10. 17 plus 10, that is 27a plus 10b. 27a plus 10b. Now over the LCM. Our LCM is 24a into a plus b. Now, nothing more than that. This one now becomes our answer. This one becomes our answer. So what you have to do is simplify this LCM. Then you work them out. Now, up to there, I don't think I have much on that, other than give a simple exercise for you to try it on your own to see if you understood the concept. So in case of any question, you can still ask on the channel. We are here to serve you. So you can do this exercise. You can do number 1, saying simplify each of the following expressions. These are yours. You are going to attempt. So 1 over a minus a over b plus 3 over a plus 4b over a. That is simple. You look for the LCM and work it out. Then we have a b. B has this 3a cubed r over 4r squared a squared. That is it. You'll see how you're going to work this out. Then C, we have 3a over 2b, then plus 4a over 3b, then plus 5c over 4b. So those are what you need to go and check on that and test yourself if you've understood the topic algebraic expressions. Up to there, I don't think I have much to say other than wish you a good day. Thank you for watching.